Okay, we're going to start with a little bit of review. Remember that point-slope form, y minus y1 equals slope times x minus x1 is the number one way to get the equation for a line whenever you're given a number of things. If you're given any information about the slope, you can plug it into that. That information could include another line, or it could include something about 2 points, and you can find the slope. And then if you're given a single other point, you can plug it into x1, y1 to get the equation of the line. Okay, let's start with these word problems, though. Mr. LaFleur pays $130 to rent a car for 1 week. He also pays $5 for every 100 miles that he drives. Write an equation and draw a graph that shows the relationship between total cost of renting the car and the number of miles that are driven. Okay, we have these things called independent and dependent variables, or I kind of like to call them, we'll call x the manipulated, the thing that you control, and we'll call y the responding, the thing that changes because of what you change. Well, you can't change the cost, so the cost would probably be y, the things that respond. But you can change the number of miles that you drive. That's something you can change. So we're going to start with the let statement. Let x equal number of miles driven and let y equal the total cost in dollars. Well, if I go back to the problem, it says he pays $5 for every 100 miles that he drives. So it's not really the number of miles driven, it's the number of 100 miles driven. So now we can say, alright, well, if he pays $5 for every 100 miles that he drives, we know that 5x is the cost he pays for the miles that are driven. 5 times 1 would be $5, 200 miles would be $10, and so forth. Okay, then we have this base cost. He pays $130 to rent a car for 1 week, so no matter what, he's going to end up paying that. And that's our equation. Again, look at it from a t-chart perspective. If x is 1, he's going to pay the $5 plus the $130. If x is 2, if he drives 200 miles, he's going to pay $10. So it makes sense. Okay. Now it says draw a graph. For this particular kind of graph, we're only going to use a first quadrant graph. So what that means is we're going to just do something like this, kind of like a classic bar graph, because negative numbers don't make sense here. This x is going to be the number of 100 miles driven, and the y is going to be the total cost. Now, we don't always like to do this, but I'm going to show you about break lines here. Now, before we do that, on the x scale, this is going to be 0, this is going to be 1, that's going to be 2, and 3, and 4, and that makes sense from the x scale perspective. Now, the y scale is interesting here because if you look at what our y-intercept is, if I go back to the t-chart, the x and y t-chart, if I plug in 0 for x, I get 130 for y. That's the base cost per week. We're going to actually start that right here, 130. I'm going to put a little squiggle here to mean that there's a little break there. Now, you cannot do that unless your teacher, me, tells you that you can do that. I am telling you for this problem, you can. But we put a squiggle for the 130. We're going to make that 130, that 135, that 140, 145, and so on. That makes sense. So then we know that it's 0, 130 is our first order pair, 1, 135, 2, 140. We have a graph that looks nice and linear, but remember that's just because we forced it to be that way. So there's our graph. Number 2. Author sells his latest book to a publisher for $5,000 plus $3,000 for every 1,000 books sold. This is very similar. Let x equal the number of 1,000 books sold. And then let y equal, it wouldn't really be the cost, it would be the income. X is the number of 1,000 books sold, Y is the total income. So Y would be equal to, it's $300 for every 1,000 books sold, that's our rate, 300x, plus our base cost is 5,000. So again, let's look at a t-chart just to get an idea of what's going on with the numbers. We'll start this time with 0. If he sells 0 books, he's still going to get $5,000. If he sells 1,000 books, that's when X is 1. Remember, X is the number of 1,000 books. You get another $300, so it's 5,300. When X is 2, you get 5,400. Or not 5,400, sorry, 5,600. Every time you add 1,000 books, you're getting $300 more. So let's go over to a graph. Like before, we're going to do a Quadrant One graph. Oops. Okay, we're going to put 0, 1, 2, 3, 4, and this is going to be X is the number of 1,000 books, and Y is going to be the income. I'm going to put a little break here, and I'm going to start at our basic income point, 5,000, and this is going to be 5,300, this is going to be 5,600, and this is going to be 5,900. The pattern is that they're increasing by 300s, which should make sense. Our first order here is 5,000, then 5,300, then 5,600, then 5,900. You may ask, well, what about slope? Are we worrying about slope? Well, of course we are. If I look at the up over here, I'm actually going up 300 and then over 1. So my slope is actually 300. Which matches the original problem that my slope would be 300. Remember, our x scale and y scales are different. On number 3, it costs $8 to enter an amusement park and 35 cents per ride. Well, letter A says write an equation that relates the total cost of the amusement park to the number of rides. You can't control the cost, but you can control the number of rides. So we're going to go about x equal the number of rides. And what y equals the total cost. The equation would be y equals how many rides you go on, x. How much does it cost per ride? 35 cents. Well, we're going to want to make that 0.35. Then we have x plus, and then we have 8, so that the total cost is actually in dollars. It makes sense here to have it in dollars rather than in cents. Part B, how much would it cost for someone to go on 9 rides? So we're going to plug 9 into x, y is equal to 0.35 times 9. 0.35 times 9. It's 12.15. So we got 12.15. Kidding, it's 3.15, so I can't read my own writing. 12 is too expensive. It's 3.15 plus the 8, so then 11.15 or $11.15. How many rides could go on without spending more than $15? $15 would then be the total cost. So we're going to say 15 is equal to 0.35. X is the number we want to know what the number of rides are. Plus 8. Subtract 8 from both sides, we get 7 is equal to 0.35x. Easy way to look at this without a calculator is actually make 0.35 be 35/100ths, or if we simplify that, that becomes 7/20ths. And so I have 7 is equal to 7/20ths times x. I'm going to multiply both sides by 27ths to get rid of the 7/20ths. Those cancel, the 7's cancel, and I get 20 is equal to x. So a person could go on 20 rides. I should probably say 20 rides. Because 20 rides would cost exactly $15. Okay, moving on to the next one. Ms. Swanson drove 300 miles one week in a rental car. The total cost of renting the car was $120. That includes the weekly rate plus mileage charge. Another week she drove 560 miles in the same rental car and the total cost was $133. Determine the charge per mile and the weekly rate for the car. I'm going to do this a little differently than maybe another teacher might. I'm going to start with B. Because here's the deal. If I say what I did before, let x equal the number of miles driven, and then I say let y equal the total cost in dollars. Keep in mind, those let statements are non-negotiable. They must be in every problem somewhere unless the problem defines the variable for you. If I have this, then I know that when you drive 300 miles, the cost is $120. Also, when you drive 560 miles, the cost is $133. That, my friends, those are 2 points. 2 points determine a line. 2 points can get us to a line. 2 points get us to a line because if I go all the way back up to the top, I have that magical equation that you need to be using a crap ton of times. So 2 points determine a line. We do that by finding a slope. Slope would be equal to 133 minus 120 over 560 minus 300. I chose that order so I could avoid fractions. Or sorry, negative numbers, not fractions. I have 13 over 260, which is going to simplify to 1 over 20. There's the slope. I don't have a y-intercept. Who cares? Y minus, let's just pick the first point we see, 120 is equal to slope times x minus 300. And I have y minus 120 is equal to 1/20th x minus 300 divided by 20 is 15. And then I get y is equal to 1/20th x, add 120 to both sides, and I have plus 105. There is the answer to part B. Y equals 1/20th x plus 105. Let's go part A. The charge per mile. The charge per mile would be that thing. What is the cost per mile? It costs, what is 1/20th of a dollar? 1/20th of a dollar would be 5 cents per mile. The weekly rate means if you don't drive any miles, how much do you have to pay anyway? That would be this thing. The weekly rate is $105. Then graph the equation, determine the cost of renting the car if it is driven 800 miles in a week. Okay, well here's the deal about the 800 miles in a week thing. I can actually figure that out right now without graphing. Because 800 miles, I'm just going to substitute that for x. 1/20th times 800 plus 105. And then you get, let's see, 1/20th times 800 is, stupid, 4 plus 105, sorry. So it costs $145 to drive 800 miles that week. Okay, now let's graph it. We're going to do a quadrant one graph again. Kind of like you should always write a paper by setting stuff up beforehand. Let's just set up some ordered pairs beforehand. So here's an XYT chart. I'm going to have, if I plug in 0 for x, I get 105. That's going to be like a starting point. Then if I plug in 1 for x, well, that doesn't make a lot of sense. So if I plug in 1 for x, I get 105.05. What's like the first number I can plug in to actually get something different? I mean, it says we want to go up to 800 miles. So let's actually go and say, instead of doing 1/105, let's plug in 100. If I plug in 100, that cost, well, let's figure out y is equal to 1/20th times 100 plus 105. 120 of 100, that's going to be equal to 5 plus 105, or 110. So 100 gives me 110. 200 would give me 115. See where we're going with this? 300 would give me 120. Now we have a pattern. So I can do this by hundreds and actually get a better amount, a better idea. That way, if you think about it, when I do this graph, if x is equal to the number of miles driven, I wouldn't want to see a graph that changes between like 0 miles to 1 mile, because you don't rent a car to go like multiple miles. You rent a car to go like hundreds of miles. So my x-axis is going to be 0, 100, 200, 300, and I'm actually going to go all the way out to 800 because the question asks me to do so. 500, 600, 700, 800. Then my y-axis, we're going to do a little break. 110, 115, 120. I can start putting the ordered pairs here, 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 here. And you can see if we're going to do this all the way up, I'm going to have to expand this line quite a bit. 125, 130, 135, 140, and 145. Okay. Connect. That looks good. And let's just compare. Let's check to see that actually when you do 800 miles, the cost of the 800 miles was 145. Let's see, what did I do? Oh, this entire graph has to be shifted down. Not like that. Oh, I see what I did. I didn't start at the right point. 0, 105 should have been my starting point. So, since I have 0, 110, I can fix this. You guys can't as easily by taking all these things and shifting them up one. That way, this would have been 105, and then my 800, 145 actually match my answer. When you drive 800 miles, it costs $145. Let's label the y-axis too. Y is total cost. Hope that's not too confusing, but error correction is a part of this, so I don't feel too bad. There we go. That looks beautiful. Okay, on and on. Oh, that's it. Aw, you don't have any more of me left.